All right, we are rolling. Okay, so I have a couple like random instructions, right? First thing, I would work with just one side of the equation, the equal sign at any time. Don't try to work with both at the same time. You're going to get a little confused. All right, and your goal is to just show that one side is equal to the other. Always look for places to factor, yes? Factor. If you're going to factor, most likely it's a GCF or you have some kind of squared term. Look for where you can add fractions together, subtract fractions, combine your fractions together with like terms. Look for options to use a conjugate, right? Or what else do I have? Yeah, conjugates. That's how you get the other stuff. Look for identities. If all else fails, try put everything in sine and cosine and see what happens. All right, and then number 5, the most important piece of advice: just try something, right? Just try something. You might not have no idea what you're doing at the beginning, but if you try something, as long as you obey the rules of algebra, you might end up in a good spot. You just don't know. Also attached number 5, do not erase stuff, all right? Unless you are 100% sure that you are wrong. But if you erase something and then come up and ask me for help and be like, I want to see what you had on your paper, okay? So please just don't randomly erase things. So show me what you have going on so I can show you either how to finish what you started or where you might have gone wrong at. All right, so first one, open for suggestions. Where do you think we should go? We need this fraction to equal sine squared. So I would start with the fraction. I would start with the most complicated side of the equal sign. Say that again. The numerator is equal to the tangent squared, right? Pythagorean identity there. So anytime you see a square term and a 1, you should be thinking, hey, maybe that is a Pythagorean identity. So now we have tangent squared over secant squared. You do not have to write equals sine squared. Just work with one side, and if you get sine squared at the bottom, you're like, hey, that's what we're saying it equals. All right. Ooh, where to go from here?
You can convert tangent into sine over cosine.
Go for sines and cosines now. That's a good option. So tangent is sine squared over cosine squared, right? For that tangent squared. What about the secant? Because it doesn't really make sense to leave it as a secant, does it? 1 over the cosine squared. So this is the convert everything to sines and cosines option. So everything written as sine and cosine. Every trig function can be written as either some form of sine and cosine, right? Every single one.
The cosines cancel out.
The cosines will simplify. Specifically, how do they simplify? Like, what's the actual operation there?
You multiply by the reciprocal.
Multiply by the reciprocal. So you take the denominator, right? You flip it, and you multiply. So what that'll look like is sine squared over cosine squared times, flipping this over would put the cosine squared on the top and the 1 on the bottom. And that will simplify to sine squared. And that is exactly where we were trying to get to, wasn't it? Sine squared. So the nice thing about these problems is it's saying, hey, here's specifically where you have to go, right? When you're doing this, this is the work that I would like to see to get there, all right? So please don't just like make a bunch of steps in your mind, because I can't read your mind as I'm grading these. It makes it really hard and difficult to try to figure out what's going on in there. Write your things down, all right? Sometimes I'm pretty good at reading minds, but sometimes I'm not, and I'm like, what in the world is going on here? All right, let's try another. We have this hot mess, and we need to prove that it equals negative tangent squared. So always work with the most complicated side of the equal sign. If you work over here, it's going to be easier to try to simplify down to that than try to take this and expand it out to make that. All right. I'm going to let you all start this. What do you think?
Tangent squared plus 1 equal, this is identity, and so is cosine squared.
Oh, cosine squared minus 1.
Oh, never mind.
That's reversed, right? But technically, you could manipulate that if you want. But we know for sure that this first one is secant squared, right? Okay. Do you want to try to change that second one?
That would be,
Or do you want to leave it as a secant squared?
that would be like the second one, the parentheses, wouldn't it be like negative sine squared?
Yeah, so this cosine squared right here would be 1 minus sine squared, right? And then you have the minus 1 at the end.
Oh, and then.
Do you want to do that, or do you want to erase that and go back? You want to keep going, or? Because you always have the option, if you put it in there, you're like, I don't like that. You can always stop and go back.
I feel like there's tangent to sine of cosine.
We don't have any tangents right now. We got rid of the tangent. Yeah. I don't know. I think you're onto something here. Because what's going to happen when we change this cosine squared into 1 minus sine squared and then a minus 1?
It'll just be negative.
It's just negative sine squared. And that is going to help us get that negative tangent, right? Yeah, so these ones are going to simplify, leaving us with a secant squared of x times a negative sine squared of x. And I feel like that we're on the pretty good track there. Because now we don't have any more pluses or minuses, yes? The secant is, the reciprocal of secant is cosine, right? So that secant, yeah, go 1 over the cosine squared, and then that's times negative sine squared. If you multiply them together, the top will be negative sine squared, and the bottom will be cosine squared, which is negative tangent squared. I'm okay if you do this, go from here to here. That's not that far of a step. I can read your mind on that one. Does that make sense? Negative tangent squared. So yeah, rolling with those identities was good from the get-go. That's not the only way to do this problem, by the way. So don't think that like, oh, I didn't see that, so I had no shot of getting that right. There were other options to get you there, okay? Especially here, if you just did that one and then didn't change this one, you could have distributed and you would have still gotten there in the end. It would have still worked out for you. So always know there's just more than one option, right? All right, let's take a look. Number 3. There are more on the back. Of course there's more on the back. This is math class, right? There's always more to try. All right. Ew, fractions being added together. But then it's equal to 2 secant squared. Remember, we always say start with the more complicated side, yes? So start with the side with the fractions. That's what I would do. Thoughts on where to start with the fractions?
Well, my brain goes cosecant, but that's 1. The 1 minus.
The 1 minus is throwing that off, right? And the 1 plus, yeah?
Wait,
So that'd be really nice if it was just like 1 over sine and
Hold on.
yeah.
Right.
Hold up.
1 minus, oh, it's not squared.
Oh, it's not squared. Did you hear that? He was like, so he's like, I got this. Like, oh, it's not squared. You're right, it's not squared. I know. What was that? No, what'd you say?
Add them together.
The fractions?
Yeah, then I know how to do that.
They don't have a common denominator, right? But ultimately, do we have to get those 2 fractions into 1 fraction? Because where we're trying to get doesn't have any plus or minuses, right? So ultimately, those 2 fractions do have to go together into 1 fraction. So unfortunately, the denominators aren't the same right now, but we can make them the same, right? And then put those fractions together. So this first one, what does it need to be multiplied by? 1 plus sine of x, the other denominator, right? And then on the top up here, you also have to multiply by 1 plus sine of x. And then what does this one have to be multiplied by? 1 minus sine of x. And so on the numerator up there, you also have to do 1 minus sine of x. All right, so I'm going to go ahead and add these fractions together. We have a common denominator, right? 1 plus sine of x and 1 minus sine of x. I'm going to write that down here. 1 plus sine of x times 1 minus sine of x. And then your numerator is the 1 plus sine of x times 1, which is just 1 plus sine of x. And then plus 1 times this, which is just that. So plus 1 minus sine of x. And so we actually took two kind of seemingly not crazy fractions and turned them into this one crazy fraction with a bunch of signs. And that's okay. Sometimes they have to get messier before they get prettier. All right, thoughts on combining those fractions? Any questions on how we got there, where all those pieces came from? All right, if there's no questions on how we got that one big fraction, where should we go from there? Huh? Solve the fraction. So you got to give me a little more direction than just solve the fraction. What about the numerator? Let's start there. Combine like terms. What's going to happen in the numerator then? Just a 2? Do you think that's good news that we now have a 2? Yeah, because what are we trying to get to? 2 secant squared, right? And we have a 2? I would say that's good news. The 2 has now emerged. We're on the right track.
It's just 2, isn't it?
It is just 2, yeah. The 1s make the 2, right? And then sine of x minus sine of x is just 0. What about the denominator? What's going to happen there?
I'm guessing you just simplify and multiply them.
Multiply it out. See what happens. 1 times 1 is 1. 1 times a negative sign and a positive sign times 1. What's going to happen there? They're going to simplify, yes? And then sine times sine, and there's a negative there, so it'll be a minus sine squared of x. It was a difference of squares that had been factored, and we unfactored it. And then now you're starting to see it, aren't you?
Yeah.
All right, what about 1 minus sine squared? That's cosine squared. And then the reciprocal of cosine was secant, so you can move that back up to the numerator and make it a secant squared. So there's our 2 secant squared of x.
Like magic.
It is kind of like magic, right? Like you take these two seemingly like weird fractions and add them together, and all of a sudden you're like, look at identity, look, there's the 2, look, oh, we can do this, now we can do this. And you might not have seen this coming, and that's fine. You're not going to see those sometimes. Sometimes you just got to give it a shot and see what happens. All right, any questions there? Any of those steps? All right, coming up over here. Tangent of x plus cotangent of x needs to equal secant times cosecant. So thoughts, which side should we work with? The tangent plus the cotangent. Why that one? Why the addition and not the multiplication? Addition's actually a little bit more complicated, isn't it? When things are multiplied in these problems, you get things to simplify, right? And they work out really well. When things are added and subtracted, it's not as nice. So I would work with the tangent cotangent first. So thoughts on the tangent plus cotangent? Switch them to sines and cosines. Yeah, there's no squares there, right? So we'll go sines and cosines and see what happens. So sine over cosine, and then cotangent's the reverse, yeah? Okay, so we got sines and cosines. Do what you just did. Put the 2 fractions together, right? So what does this first fraction need to have in its denominator? What do we have to multiply by? We have to multiply by the sign. So in the numerator, you also have to multiply by sine. And then the second one, what does it need? It needs cosine. So in its numerator, multiply by cosine. So the common denominator is the sine of x and the cosine of x. And what happens in your numerator?
Sine
Sine squared plus cosine squared makes a 1. So it's 1 over sine of x cosine of x. So there was a Pythagorean identity that emerged in the middle of that.
But now we can switch sides because secant is 1 over cosine and cosecant is 1 over sine.
So 1 over the sine is the cosecant, right? And 1 over the cosine is the secant. We could just keep going here. Yeah. And secant, cosecant being multiplied is what we're looking for, isn't it? So a nice little reciprocal at the end. I guess double reciprocal. 1 for each. All right, how you doing so far? Do you like them more where it tells you where to get to?
You know, kind of because you know when you're right, but then again, you want to like know if you're going the right way.
Yeah. So it is kind of like this nice like self-check. Did you get the right thing at the end?
Oh my goodness, these other two have really weird sides.
Well, let's give them a shot. So number 5. All right. Oh boy. Yes.
Yeah.
Whew. Okay.
This one's worse, so I'm not as good at this one anymore.
So we have secant of x plus tangent of x equals cosine of x over 1 minus sine of x. Thoughts?
Immediately, I want to make everything sine and cosine.
So immediately you're like, just change everything to sines and cosines and let's see what happens. So you're saying that since this side is already sine and cosine, you want to work with this side? All right. So secant is 1 over the cosine of x. Tangent, sine of x over cosine of x. By the way, make sure you're putting your x's on there. To just say sine and cosine without the x's is not actually saying anything. It's like saying a square root without putting anything underneath of the square root. You're like, square root of what? I don't know. There's nothing there. So make sure you put your x's in there. I feel like maybe this is a good spot. I don't know. Where should we go from here? You can add them together. So, hey, that helps us get a common denominator. They're already there. They're both cosines. 1 plus sine of x. And that is so close to the answer that it hurts, doesn't it? It's like, shoot, how close can you be without actually being there?
But now you just have the identity.
So now you have what?
Use the identities.
Yeah, so you can keep using identities if you want. These are all just no squares, right? No squares. If there's no squares, the identities might be a little bit harder to use. Because we already used reciprocals and we used the quotient already. So thoughts? You can't just flip it, no. You have to have a good reason to flip it. Plus, if we just flipped it, we would be off on the plus, right? There's a plus sine of x and a minus sine of x, so they would be off on those signs. Signs is in not the signs, but the plus or minus signs. Yeah.
Switch to the other side and take the conjugate.
Yeah, so now if you get stuck, you can always go to the other side and work with the other side. So let's work over here. And then if we can show that this equals this, then you're still okay, all right? Because then you would just essentially be like a big circle, right? So this going straight down to get to that, you could work here. Once these two match, then essentially you have your connection there, okay? So looking at this one, your suggestion is multiply by the conjugate. Why does the conjugate jump out to you there?
Because we need to.
You got to do some flipping, right? Some flipping's happening here. And anytime you see 1 plus a trig function or 1 minus a trig function and there's no squares, a conjugate is probably a good way to go, all right? Because what's going to happen is you're going to turn it into some squares. So the conjugate of 1 minus sine of x is 1 plus the sine of x. And when you multiply it on the bottom, you also have to multiply it on the top. And I feel like that's a good thing because 1 plus sine of x is what we have on the top, isn't it? Yeah. So you can go ahead and say equals now because we're going to work this side. So the numerator, cosine of x, 1 plus sine of x. And then the denominator is where all the magic happens, right? On the conjugate. Gavin, good morning. What's going to happen in that denominator when you do 1 minus sine of x times 1 plus sine of x? You're going to get a 1 minus sine squared of x. So 1 times 1 is the 1. The 1 times the sine and the negative sign times the 1, those are what's going to simplify, right? And then you'll have negative sine times sine, which is negative sine squared.
And then that
The denominator turns into a cosine squared. So cosine of x, 1 plus sine of x on the top, cosine squared on the bottom, and then the cosine on top will simplify with just one of the cosines on the bottom, right? And so this will simplify with just 1, so it'll be 1 plus the sine of x on the top over cosine of x on the bottom. And these two are now equal. This one equals this one. So you're good. You don't have to like show any backwards motion or whatever. So if you get stuck on one side, work with the other side and see if you can show that those two things are equal. By the way, from here, what we could have done is multiplied the top and bottom by cosine. That would have been where to go next. Or you could have multiplied by the conjugate of the top, right? That would have worked as well. But you might not have seen that, and that's okay. So always know that you can work both sides of your equal sign. All right, last example, yes? All right. So you want to work with this side here? I would work with this side because the denominator is more complicated, right? Yeah, so I'm good with working with that side. You want to change those to sines and cosines, or do you want to maybe do something else first? The cotangent squared is a Pythagorean identity, right? I don't know, you all tell me. Cosecant squared minus 1? Yeah. Minus 1 over 1 plus cosecant of x. So we're working on this left-hand side. Where to go from here? Huh?
That's an even crazier fraction. I was gonna say turn them into 1 over sine that way.
Yeah, I wouldn't go to sines yet. Although the nice thing is we know cosecants can go to sines, right? So we know at some point we're probably going to want a reciprocal. But I wouldn't reciprocal yet when you have a fraction, because then you'll end up with fractions inside of fractions, and then you just have a ton of fractions.
Also
and
being added and subtracted from them.
yeah, and you have some plus or minuses, plus 1, minus 1s in there. So whenever you have all those fractions and plus or minuses, you just want to cry, right? You could do a difference of squares with the numerator, right?
Yeah.
That is a difference of squares, yes. So cosecant squared minus 1 would factor as cosecant plus 1 and cosecant of x minus 1. And in the denominator, you have 1 plus the cosecant of x. Yes, the 1 plus cosecant and the cosecant plus 1. It doesn't matter the order which you add the 1, right? If those were subtractions, though, you'd have to be really careful, yes? Because subtractions, the order matters in which you subtract. But for adding, those orders don't matter. So those two will simplify. So this side is now cosecant of x minus 1.
Turn it into a sign.
Now go to signs. All right. So cosecant is 1 over the sine of x, and then we have the minus 1 still. We are so close, yes. You can feel how close we are, can't you? Super close. You need what? If you get a common denominator, you can put it into one fraction, right? So if you remember, our answer is just one fraction, yes? So if you get a common denominator, you can put this in one fraction. So the common denominator is going to be a sine of x. So this minus 1, you should change to minus sine of x over sine of x. And now you can put them together. So 1 minus sine of x in the numerator over sine of x in the denominator. By the way, if you didn't see that last step of changing that 1 into sine of x over sine of x, you could have, instead of going from here to here, gone back and started this side and tried to show it was 1 over sine minus 1. And how would you show that this is 1 over sine minus 1? You could split it into its two fractions, right? Because it's just one thing in the denominator. So you could have said 1 over sine of x minus sine of x over sine of x, which would have given you 1 over sine of x minus 1. So you could have gone back when you got really, really close. You could have gone to the other side and tried to make it equal as well. All right, what y'all think? I did warn you at the very beginning of the trimester that this might be your least favorite or maybe your favorite. I don't know. Either you like it or you don't, I kind of feel like. So, no. You don't like it?
I mean, it's not.
It's honestly not that difficult. It's just you have to try.
It's just
a bunch of
tedious.
stuff.
It is tedious. I'll give you that. Because you can try something and then get in a position you're like, I don't know where to go from here. So then you have to work backwards, right? So it's one of those, like, when you really like math, you like math because it's like you do this and then you do this and then you do this and then you get your answer, right? But with these, you might try something and you might not get there right away. So you almost have to like backtrack and kind of like find a new path. And so, yeah, that's why some people either like them or don't like them. All right, so you're working on the next two pages, so 37 and 38. And we're going to work on them for the rest of class today and in class tomorrow, okay? So hopefully between today and tomorrow, you should have plenty of time to ask all the questions that you want, all right? All right, and then on Thursday, we're going to talk about something, inverses. You've heard of them before, so we're going to talk about those. And then Friday, we'll review. And then I know I hate giving you a Monday test, but test on Monday, okay? Yes? All right. And because it's a Monday test, I will even let you use your orange sheets. Does that work for you?